Good afternoon, ladies and gentlemen. According to the suggestions, let me deliver my presentation in Spanish. Please pick up your receivers for translation into English. At the reception desk, my gratitude goes to the organizing committee, especially Carmen Skrik and her team. Thank you for inviting me to input into this symposium, this summit. I'm a layman in this community, so I'm enjoying a lot because I'm learning a lot from you. My background is not as excellent as Dr. LaGuardia's analytic chemistry. I'm a sort of physicist, chemist, so to speak. So this is my bias in my presentation. Perhaps I'm not so much set on the core of the issue that appeals to us. Anyway, let me underscore passive exposure to nicotine. Everything is related here. Everything goes together. It generates many topics for us to have a look at. This is how my presentation goes. On the screen. First, motivation. Next, targets. Some methodology. It always helps, because it clarifies for you the validity framework, how valid your results, your outcomes are. Let me discuss my outcomes, and next the message to bring home for the future if we happen to meet again. I did like the presentation by the first speaker today in the morning, because I had a similar slide in order to discuss the role played by nicotine. Nicotine is a dangerous drug, but it doesn't relate to cancer. Therefore, lung cancer and other disorders that are the main reasons for tobacco-related death go together, as already said, with compounds generated by combustion of tobacco. Not only to nicotine. Some years ago, this led to this proposal by the British Order of Physicians to save nicotine and modify the tool that delivered nicotine to the patient in order to suppress combustion, smoke. Therefore, the suggestion was very clear about it. Health and life expectancy of smokers can improve if we eliminate the smoke and we save nicotine. Now for the two main inputs into this direction, the two main developments that emerged recently. It is of hat. I'm not discovering again the wheel. I'm not discovering the Mediterranean, since we are off the sea now. On the one hand, e-cigs, and second, combustion-free cigarettes by Philip Morris, based on heating, not burning. This is the principle. My targets are, in my presentation, on the screen. Let me discuss the content of nicotine available in smoke, from a mainstream cigarette, in vapor from e-cig, and combustion-free cigarettes, in the dimensions of both passive and active smoking. Next, let me add two things, a comparison and a message to bring home. Let me start with the method. Actually, my methodology goes through three stages: generation, collection, and analysis of smoke, or aerosol. Aerosol generation is based on a smoking imitation device. It is a software that controls all parameters that influence smoking, the practice of smoking, i.e. the length of the puff, so on and so forth. And this is checked by this remote control device. I collect some puffs and I analyze. This is the regime of puffs, so to speak. There are different ways to approach them. The most important ways to approach it are on the screen. The one I chose is HCI, Health Canadian Intense, HCI, that somehow mimics a case of a smoker that smokes perhaps a bit more. I mean, he smokes for 2 seconds, 2 puffs every 30 seconds, smoking 55 ml of aerosol or vapor. The same applies to second-hand smokers. This is at the core of my presentation. Second-hand smokers, I've approached them changing the distance and changing the angle. Of course, let's change the angle. There is a gap between going to a restaurant and being in front of a vapor 40 centimeters away from you and having him at an angle of 45 degrees versus the place where you are. There are interesting outcomes out of it because both parameters, distance and the angle, go together, hand in hand. There are cases in which the angle prevails. In some other cases, because of collision, multiple collisions, the angle dilutes and doesn't weigh at all. Now for the analytical techniques, we use the laser spectroscopy and chromatography. The previous speaker did define the power and the accuracy of chromatography. Laser spectroscopy has, there is some fun about it. It is useful because, let me tell you, in chromatography we used HPLC, GC gas, GC gas masses, GCMS, a popular technique used by my team. REMPI goes together with GC because it looks for a molecule in the middle of 0.1 million molecules around. The most important outcomes I'll discuss today come from GCMS, which is a very sensitive device. I won't talk about spectroscopy today because I have no time for that, but we do work a lot on Raman spectroscopy because it is non-invasive in character.
I would say laser technology of diodes has been so developed that a diode sensor for nicotine or any substance without touching the smoker or the environment detects it with a lot of precision. For example, for liquors. This is an example of Raman spectroscopy of transmission developed by us to measure in situ the glycols. Here I present the results, just one result, wonderful. You see the glycols that are very much present in vaping. Now we are going to go straight to the results because I don't have a lot of time. ICOS. This slide was given to me by Dr. Philip Yetman from Philip Morris, so it's not a new concept, but it's a very important one in order to understand and to apply, and also for later studies. The traditional regular cigarette has a combustion stage here at high temperatures, 750 degrees Celsius. With these temperatures that are so high, you achieve several things. On the one hand side, the thermal dissociation of the compounds. These thermal dissociations of the thousands and thousands of compounds that come out of the tobacco produce radicals that are traveling through the tobacco, and they are absorbed in the surface of the tobacco, and they find another radical. So if you collide two radicals that are in the gas stage, it's very difficult that they have a direct reaction because they are unstable compounds and they need to stabilize. They need a push to remove the excess energy so that a compound will be formed. But in conventional tobacco, this mesh, the tobacco at almost 1000 degrees is the perfect bed where the radicals can be absorbed. So hundreds and hundreds of new compounds are created. And we need to understand that. It is easy to understand because if we eliminate the temperature, all this chemistry that is homogeneous in the gas stage and heterogeneous in the surface is eliminated. And this is the great achievement. This is where we are today with the e-cigarette and also with the heat-not-burn cigarettes. Let's say, well, I'm not convinced, what you say is very beautiful, but I need an example to see it clearly. You need to demonstrate that things are as you say. Well, wait for a minute, let's see. Here you have it. This is a mass spectrum, a quick one of mass chromatography. For a conventional cigarette, the universal cigarette, the 3R, F4, and IQOS, because the scientist at a certain time needs to see the forest and then get to the trees. And what is this forest telling us? It's telling us that here you have a flat scan, and there you have, in the upper one, you have several peaks, many peaks. Just the fact of hitting it at 300 versus combustion has eliminated many compounds. And it has reduced in 50% the nicotine. Give me an example that is more specific. Well, you have it here, the low weights from limonene to all of them. You can see the amount of peaks in the upper line and the few ones that you have in the lower layer. Some of them said, well, they are decaffeinated. Well, if you make it decaffeinated so that in a meter you won't get anything, then that's all we need. Well, explain to me in a clear way, more in a quantitative way. Well, here you have it. The ones that are more significant, you have 37 versus 12. In the non-nicotine contents, 82% is reduced. If you have 100 compounds, only 18 compounds are left. The number, the figure, and the amount. And what happens with the e-cigarette? Let's see. Well, with all my very distinguished colleagues, I will not get in depth about the way it works. It's a battery that is connected to a resistance, and it makes the liquid, it turns the liquid into vapor. Nicotine of the regular cigarette, depending on how many puffs, and in the right-hand side, the electronic one. You have half of nicotine versus the traditional cigarette and versus the IQOS. But since my talk is about passive smokers, second-hand smokers, let's talk about this. If you locate the passive person in front of the active smoker, of the passive vapor, and you vary the distance, the amount of substance decreases as r to the power of 2. So from 1 centimeter you would go to 1 meter and you would get 100 times less. It's a result that you can see here at 30 and at 100. And if you change the angle, the distance gets shorter. At short distance it decreases a lot more than at long distance. Why? Because if someone breathes the vapor in front of you, the overpressure that the person who vapes is having on the atmosphere introduces a translational moment in that direction, so that an angle of 45 degrees is not affected by it, because the overpressure is much higher than the rebalancing by molecular collisions. Well, it's quite curious. I can be in a restaurant 30 centimeters from a person who is vaping, and if that person is not in front of me, I'm not a second-hand vapor. And the same with IQOS, vapor smoker. And what about the collisions? You mentioned the collisions before. Well, the collisions is like a friend, because if you go to a distance of 1.5 meters, the collisions diffuse isotropically the nicotine. So it's quite curious. Physical chemistry of the production of tobacco, of the combustion of tobacco, of vaping the tobacco, and the dynamics of fluids around the passive vapor. The physics field is telling us, well, what are they telling us? That the passive vapor, it does not exist. Where is the passive vapor smoking? 600 nanograms. The e-cigarette, I have to multiply it by 100 in order to see it, and in the IQOS also multiply it by 100. In the configuration of 1 meter. So the nicotine that can reach this passive vapor is not significant at all. There's no study that demonstrates a damage to passive vapor with these levels of nicotine. Perhaps in the future we will have such a study, but right now there's no study like this. What is my conclusion? Because I don't want to tire people. The conclusion is very clear. Well, here we have two phenomena. One, because of the physics itself of the generation of smoke or the generation of the aerosol, the nicotine and drops 50%. I need to clarify this. You drop 50% when you put the same amount of nicotine in each of the cigarettes. So if you, in an e-cigarette, you put 10 times less, then it drops 50 times. This is specifically here we put 0.7 milligrams per cigarette, and you see a drop in nicotine in 50%. But the significant data also is that if you go 1 meter away, wherever you are, even though if you are in front of the people who is vaping, thanks to the collisions, 2 magnitudes are being dropped. If you are at the meter distance of a vapor who puts 0.1 milligrams, then you don't get any nicotine at all. Let's be clear about it. because the data, that's what the data say. The existence of the passive vapor has not been proven, but I want to say, well, you cannot put obstacles to the field. We are in a moment where the technological and scientific development, not only with non-combustion, but the scientific development itself will generate cigarettes that do not cause any damage at all. It's not just harm reduction, there will be no harm at all, and this is the future. Thank you very much for your attention. Thank you. Do you prefer the questions in English or Spanish? In English. Well, I don't want, being Spanish, I cannot speak to you in Spanish. Let's make things simple. Well, I agree completely with you, but I don't believe that nicotine is the target molecule, because obviously the passive smoker or the passive vapor who becomes addicted to the nicotine because someone is smoking next to him or her, I believe that for tobacco consumption even is not evident, is not obvious. So what I want to encourage you to look for, to focus on the smoke, not on the nicotine. We all agree that what is toxic is the smoke, not the nicotine, and we need to find the components of the smoke. And in that case, when we focus on nicotine, the situation is much more favorable. Thank you for your observation. Perhaps I didn't emphasize it enough. We chose nicotine because we needed a starting point, since is where the highest peak took place. But this is a linear scale and also a logarithmic scale, so the situation regarding the other aspects is going to be much more advantageous. But I don't dare to say it because we need to measure it first. And if we look at the spectrum in this slide, this is a logarithm scale. Here you have a small peak that is 15 times less than in the upper line. In the upper line, in the lower line, here we have another peak that is 20 times lower than the peak in the upper line. So we look for the worst case scenario. So we need first to make sure about the data. But I thank you for your question, because your proposal is very positive. The non-existence of the passive vapor regarding other components of e-cigarettes or regarding IQOS. Any other question? Can I ask you a question? A large part of nicotine, I believe 94, 98% is absorbed by the user also. So the amount of nicotine, especially in the gas stage, is very small. So what you're showing is that something very small becomes even much more smaller, but it is small to begin with. Exactly. Yes, a very interesting observation. The nicotine has several isomers and enantiomers. It has not been demonstrated that all the enantiomers are equally harmful. In fact, we understand quite a bit about chirality, and there are many studies about selective absorption of enantiomers. But for me, I get the impression that there might be some nicotine that, because of its chirality, is barely absorbed in the lungs, by the lungs. That's interesting. And another question, how do you compare it with the smoke from traditional cigarettes? You're talking about this diffusion, this spreading, these thermal conditions. So what happens with the smoke from the cigarettes? It creates aging because of the oxidant processes. The smoke from traditional cigarettes, the smoke from tobacco is included here because the passive smoker, the second-hand smoker, here has absorbed what the active smoker is exhaling plus the smoke of the cigarette. So these results, they do include the use of the absorption of the smoke. In this case, the tobacco smoke does not have pressure. It comes upwards. Nobody is pushing it. So it has the direction of the ZX and not the Y axis. You should be on top of the smoker to be a passive smoker of the smoke that is coming out of the cigarette. But when you go to the restaurant, you don't ask the waiter to place you on top of the smoker. You ask him to place you next to someone else. There are two sources of passive smoke. Sorry, we cannot translate without the microphone. Here you have it. Here, what is missing is the person who is smoking. I wanted to show a person, but I did not get the permission for it. And I didn't dare to put the picture of anyone. So here, there's a human being who is smoking in this diagram, and you get the smoke that the person expels. There are two sources of passive tobacco. People don't take into account the fact that in vaping, you only have the source that is exhaling the main vapor. We don't have that transfers, the cross-sectional smoke, the one that goes upwards, because it's through convection. The cigarette is lit and nobody is puffing upwards. It just, because of convection, it goes upwards, but the passive vapor does not have the source. You only get what the vapor is exhaling. That's why it is 100 times less.